Class, welcome back. We are going to continue our work on composing functions. Now, last video when we were talking about composing functions, everything we were doing was just numbers, right? Plugging a number or a value into a different function. This is going to be a little different now, okay? We're plugging functions into functions. All right? So remember what we do. Whenever we see something that looks like this, f of g of x, we like to rewrite it. We like to write it as f of, and then what do? We put the g of x inside of the f function. Alright, so as I continue on, hopefully we can agree that all I'm going to do in my first step is say, oh, g of x. Well, I know g of x is 2x squared plus 3, so I put 2x squared plus 3. Okay? So that's the easy part. Here's where people run into some confusion and people kind of get nervous and they start doing things that they shouldn't necessarily do. Alright, what does this say? This says that I need to take the f function and whatever I have inside here, I need to input into the f function. So let's read this. F of x is equal to the input squared plus 1. Alright, the input squared plus 1. So what I'm going to do is I am going to have my input squared plus 1, and now I just replace, okay, 2x squared plus 3. Now, please be careful. I can't stand when you guys just distribute that squared sign. That's not how this works. Remember, this is an entire quantity being squared, which means I need to write it twice, like that. And then don't forget our plus 1. Now, at this point, you guys have to understand how your own comfortability level, okay, or your comfort level. Wow, comfortability. I would want to a lot of the time see you guys foil this because we were making mistakes on this on past quizzes. All right. So remember, we do the first, right? So 2x squared times 2x squared is 4x to the fourth. Now the next piece comes from both the outsides and the insides. And in this case, 2x squared times 3, 3 times 2x squared, well, both of those individually are 6x squared. So when I combine them together, I get 12x squared. And then the last part, 3 times 3. Well, that's 9. So I could add 9 and then add 1. But what am I going to do? I'm just going to kind of combine them now. So 9 plus 1 is 10. All right. This is f of g of x. Let's try the next one. All right, same idea, same concept. I just rewrite it now. G of f of x. Okay, so now I have g of, and I input my f function, which is x squared plus 1. I'm going to input that into my g function. So g function says 2 times my input squared plus 3. Alright, so 2 times my input squared plus 3. Now I plug in the x squared plus 1. And now do what you need to do in order for you to do this correctly. I'm going to rewrite it for the sake of notes. And so you guys understand what we're doing here, right? I need to FOIL. Well, x squared times x squared is x to the fourth. X squared times 1 would just be x squared. Another one, so this is plus 2x squared plus 1 plus 3. Alright, now I go to distribute, right? I need to distribute this 2 to everything. So I have 2x to the fourth, that's a 4, plus 4x squared. And then, well, 2 times 1 is 2, plus another 3. I'm just going to, one time, change this to a 5. Okay? So hopefully, this is making sense. Again, the trickiest part is understanding how to plug this in correctly. People make goof-ups on this all the time. Alright, so please be very careful. Let's move on. Let's try some more. Alright. F of g... Oh, I should have changed colors. F of g of x. Alright, so f of g of x, my g of x function is negative 2 over x, okay? Negative 2 over x. Well, what is my input, or what is my function that I'm plugging into? 1 divided by the input plus 3. Alright, so 1 divided by the input plus 3. Now I can put the input in, that I understand exactly where it goes. Sorry if that's tiny. Let me see if I can make that a little bigger for you. Alright. Now, to solve this, or to simplify this, I should say, sorry, we can't leave it like this. We have complex fractions here. We have fractions inside of fractions. We cannot do this, or leave it, I should say. There's options here. If you want, you can get a common denominator in the bottom and kind of see what happens. For me personally, though, I think the easiest way to kind of simplify complex fractions is to always do this method. Okay, so I have my top, I have my bottom, and what I am going to do is I am going to multiply the top and bottom by the common denominator. Okay, I'm going to do that because, and well, again, why can't I do that? I want to change the value of this fraction, right? I want to change the value of this fraction. Or I shouldn't say that. I don't want to change the value of the fraction. I want to change how I write the fraction. Okay? Same value, different way of writing it. So to do that, think about, like, if you have 1 over 1, well, I can rewrite that if I multiply by 5 and 5. That's still 5 over 5. It doesn't change the value, it just changes how I write it. So I'm going to do that with this. And again, the method is to find the common denominator. Well, 1 over 1, so common, or denominator of 1, x, 1. So what I'm going to do is I'm going to multiply top and bottom by x. Alright, so when I do that, that should be pretty nice. 1 times x is just x. When I distribute this now, right, there's two pieces. I have to multiply this x by both of these pieces. Well, negative 2 over x times x just becomes negative 2, and 3 times x is 3x. I would be okay with this if you wanted to write it, like switch the order, something like that. That is also more than okay. Alright. If you had gone the other method, like if you had got a common denominator, let's do that real quick, actually. So let me rewrite this. 1 over negative 2 over x plus 3. Alright, well this has a 1, right? So I'd need to multiply this by x over x. So what would happen? This would have been 1 over negative 2 plus 3x all over x. And then what would we have done here at this step? Well, I would have ended up saying I'm dividing by a fraction, so I would change and I would multiply by the reciprocal, and I would get the exact same thing. Okay, so multiple options on that one. Alright, g of f of x, so we rewrite g of f of x, or g of, my f function is 1 over x plus 3. 1 over x plus 3. So we go ahead and we do what? We plug, or we see that our g of x function is negative 2 over the input. So I write it, negative 2 over the input. So when I write 1 over x plus 3, we have options. This we've done before. If you have a fraction in the denominator, you can always multiply, right? If you're dividing by a fraction, you can always multiply by the reciprocal. That's kind of like the keep, change, flip. What I'm going to do, though, is I want to try and use the same exact method that I did over here, just to kind of get you guys used to it. What do I have here? I have one term in the numerator, I have one term in the denominator. Denominator of the numerator is 1, denominator of the denominator is x plus 3. So our common denominator here that I'm going to multiply top and bottom by is x plus 3. And when I do that, well, this is nice, right? Negative 2 times the quantity x plus 3 all over, well, what happens here? When I take 1 over x plus 3 and I multiply it by x plus 3, I'm just left with 1, guys. Alright, so I finish this up by distributing negative 2x minus 6 is g of f of x. Alright, so we can also have radicals, like in this next one. Once again, rewrite f of g of x, and then we know g of x is 1 minus 2x. So now what does it say? It says that we are going to square root the input minus 2. So square root the input minus 2. 1 minus 2x. What happens here? So when I do 1 minus 2x minus 2, I'm just left with negative 2x minus 1. And guys, we're done with that, right? We can't simplify that anymore. So we are completely done with that one. Next one is g of f of x, or g of the square root x minus 2. Alright, so when we look at our g function is 1 minus 2 times the input. Alright, so 1 minus 2 times the input. This one we're pretty much done with already. We can't really reduce anything. We can't multiply this in because this is in the radical. This is a value. Alright, so here we're just saying, we're basically just getting rid of the parentheses and writing our answer, g of f of x. Okay, so there are some, I don't want to say easier ones, but these are good to warm up with. Alright, so let's move on to the next page. Move up to the top. This top section is something that we're going to be doing in a little bit. It helps us determine if things are inverses or whatnot. But really what I want you to focus on right now is that I want to have perfect work explaining this part, and then a whole new set of work to explain this. Alright? So it says that I need to show that f of g of x is equal to x. Well, that's kind of like my first step. And then after I'm done with that, I'll move on and I'll do the rest. So, f of g of x. F of g of x. Equals f of, well, g of x is 1/3 x plus 4. Alright, 1/3 x plus 4. So now remember what we do. We look at our f function, right? Our f function says 3 times the input minus 4. So I'm going to write it 3 times the input minus 4. When I go to write this, so 1/3, I put in my input of 1/3 x plus 4. Well, what's going on here? What's going on here? I need to multiply all of these things together, right? Don't overthink this, okay? Remember what would happen when you multiply. When you have multiple things being multiplied by each other, you don't distribute the 3 to everything, okay? Like this 3, I just want you to kind of multiply with this 1/3, because what happens here? 3 times 1/3 is 1. X plus 4 minus 4, or x plus 4 minus 4. Oh my gosh, it worked. We got it. Alright, f of g of x is equal to x. Again, be really careful here, guys. I just want you to understand that if this is 1/3 times the quantity x plus 4, and then you multiply it by 3, well, really, that 3 and the 1/3 just kind of cancel each other out, and that's what we were looking for. Alright, let's try the next one, which is g of f of x. So g of, and then my f function is 3x minus 4. 3x minus 4. Alright, so I come back. My g function says 1/3 times the quantity input plus 4. Alright, so 1/3 times the quantity input plus 4. So now that I know my input is 3x minus 4, this one's a little bit different, okay? It's a little different. Remember, parentheses first, right? So I'm probably going to want to clean this up first, which means I have 1/3 still on the outside. Well, 3x minus 4 plus 4, what happens? Go away, just 3x. And then 1/3 times 3x is x. So I have shown that both f of g of x and g of f of x are equal to x. And that is something that we will talk about in the very near future. Okay, that has significance. Okay, whew. We're getting there. At this point, guys, I would say if you're feeling okay on these, it might not be a bad idea to try some on your own. But again, I'm expecting you to do all of these, so don't just stop the video and say I'm done. These are really good problems, and they're a good sampling of what you might see, so these would be very, very good to understand how to do. Alright, so f of g of x, f of g of x is the same thing as f of, and well, g of x is square root of x minus 2. X minus 2. Alright, so we look at our f function. Our f function says input squared plus 2. Input squared plus 2. Let's see what happens when I put in my input that I have. Alright, the square root of x minus 2 squared plus 2. Well, what happens when I square a square root? You guessed it. You're just left with that original quantity. So x minus 2 plus 2, and we know that that is just equal to x. So f of g of x in this situation is x. How about the next one? Let's take a look. Now I have g of f of x, so g of f of x, and we know f of x is x squared plus 2. X squared plus 2. So now, if our g function is the square root of input minus 2, that's what I'm going to write. Alright, square root input minus 2. When I now put in the input that I have, x squared plus 2, well, what happens here? Can we square root yet? No, we need to clean up the quantity that's underneath the radical first. So this is actually pretty nice, right? X squared plus 2 minus 2 just becomes square root of x squared, and we know that that is just x. Alright? Okay. Getting there. We're almost done. Sorry about that, guys. Okay. So as we move down to the bottom of page 53, we have f of g of x, and we know g of x is negative 4 over x, so negative 4 over x. Alright, well, we know that our f function is 1 over the input plus 7. So 1 over input plus 7. At this point in time, guys, again, I would say I have a complex fraction. The easiest way to get rid of a complex fraction is to multiply both top and bottom by the common denominator, or by a common denominator. So, well, no denominator, x. Alright, so this one's nice and easy. X over x. And this is good. 1 times x is just x. Negative 4 over x times x just becomes negative 4. And 7 times x, of course, is 7x. This is more than okay. If you wanted to rewrite it, I would be okay with that as well. X over 7x minus 4. Either one of those options is more than okay. They are both equal to f of g of x. Okay? Alright, how about on this next one? Now it's g of f of x All right, our f function is 1 over x plus 7. So that is our input for the g function. Our g function states -4 over input. Okay, -4 over whatever our input is. So 1 over x plus 7. Again, you have options here. You can do what we were doing when we were doing operations, and you could just say this is -4, and then you can multiply by the reciprocal. Again, just because I want you to get used to this method, take the common denominator between 1 and x plus 7. Well, that's x plus 7. So we have -4 times the quantity x plus 7. And what happens here? 1 over x plus 7 times x plus 7 is just 1. So we finish by distributing. -4x minus 28 is g of f of x. Alright, almost done. I know this is a long one. This is a good example, definitely something that we should understand how to do. Okay, fractions are getting a little trickier. So, we start the exact same way. We know that this is f of g of x, and now this time g of x is x plus 5 over x minus 1. So what happens here now? When we look at our f function, it says we have the input minus 2 over the input plus 3. Alright, so this is more challenging. I have the input minus 2 all over the input plus 3. So again, I'll change colors. Hopefully this will help. This is x plus 5 over x minus 1. This is also the input, x plus 5 over x minus 1. At this point, guys, this is where that trick for simplifying complex fractions comes in handy. I have 4 pieces. I have a denominator of x minus 1, 1, x minus 1, 1. So my common denominator is x minus 1. This is good. This is good. We put our equal sign and we start distributing, okay? Well, x plus 5 over x minus 1 means what? These will cancel and I'll just be left with x plus 5. Then I have to distribute this as well. So -2 times x minus 1. And now this is all over. Once again, the x minus 1's will cancel. So x plus 5 plus 3 x minus 1. Alright, we're getting there. We're close. X plus 5, distribute correctly, -2x plus 2, and x plus 5 plus 3x minus 3. Lastly, just clean this up. So what do we have here? We have -x plus 7 all over, what is that, 4x plus 2. And that is f of g of x. Alright, so guys, that really is just a bunch of algebra. This is the step that I need you guys to understand. Why we're doing this, what's the reason, how it works, and notice, right, like we're going from a crazy looking fraction to something that's not as bad. Okay, so this is good. Alright, last part. Last part. We just have to redo this, but now we're going g of f of x. Alright, and we know that f of x is x minus 2 over x plus 3. So again, what do we do and what have we been doing? We say our g function is the input plus 5 all over the input minus 1. So we write it input plus 5 over input minus 1. I really like seeing this. I feel like this is a surefire way to not make mistakes if you really kind of leave parentheses to help you out. So now that we know how it works with our inputs, we just actually put the inputs in. X minus 2, x plus 3, and same input, x minus 2, x plus 3. This one is going to do what? What is our common denominator here in both or of both of these pieces. You said it. X plus 3. Alright, so when we go and we distribute, well, remember these are going to cancel each other out, so we're just left with x minus 2 plus 5 times the quantity x plus 3. And then we'll have in the denominator, again, these will cancel, so we'll have x minus 2 minus 1 times the quantity x plus 3. Alright, when we distribute, x minus 2 plus 5x plus 15 all over x minus 2 minus x minus 3. Alright, be very careful. Make sure to combine correctly. We have 6x, we have positive 13, and we have cancel, right? X and negative x cancel, so negative 2, negative 3, minus 5. G of f of x. Alright, so this is a good sampling of problems in terms of composing functions. Please make sure to work on these, make sure to ask questions. I hope you have a great day. Later.